Day 8. Let's see what we got. Excuse me. Excuse me again. Some sort of mapping problem, okay. Think we can deal with this. Not sure yet. Let me read it again. Wait. Okay. Left. Left. Okay, so the left. Left. Okay, so that's 6 steps. I see now. I think we can just simulate it. Probably. I don't think we have to do this in an especially clever manner. Probably. So we got a map of a string to a pair of strings. It's probably an okay way to do this. I don't even have a good name for this. I'm just going to call it map. Oh, okay, I'll do my record. Okay. So... and let's see if I can cheese this. So order input is going to be, I'm going to have instructions. No. If you repeat it, it's not a thing. I think repeat would be very handy, so not sure why you can't do that. Okay, whatever. because I should get rid of the unnecessary stuff. Okay. Just to be clear. I can only imagine that part 2 is going to be pretty interesting. What I really want is like a generator that'll continually give me the input order. It's kind of annoying I can't do that, but oh well. Maybe, yeah, it's pretty ugly. Right. See if that works. Not sure it does. This modulo step is supposed to replicate, just so we don't run out of input for the directions. Let's see if this works. Okay, so easy simulation, awesome. Okay. Okay, there's a parallel thing now. Excuse me. Yep. Nah. Gotta be kidding me. Okay. Well. Anyway. Goodness. Okay. So they changed the problem to do all of them at once. This could be an issue for parallel, maybe, just because, well, actually, there's not that many that start in A. So it just might take forever to get to that point, so I'm not sure what's going to happen if we simulate it, but don't have a better idea right now, so I'm just going to think on simulating this. So I'll actually keep that as a character now. Oh, wait, nope. Not as a character. Okay. Keep it as a string, I think. Okay, so they're still unique identifiers. What if we have a vector of occurrence? Oh, whoops. Okay. So that's all the ones that end in A. Feels like doing the update for all of these simultaneously could take perhaps too long. So how do we know if we're done? We know we're done if all of occurrence all of the end with Z, I think. Let's see if that's what they meant. Yeah, I believe that is what they meant. So if ends with Z, break. Yeah, we'll do it like that. So now for each of the inputs, you want to set them to I think we do the same logic actually. This is pretty weird, so I don't know about this. Seems like it's not quite there yet. Oh, well, get rid of that. Well, rename that. Okay. Six there. I'm concerned this will take too long though, so yeah, this takes too long. Okay. So let's think. Instead of simulating it, how can we know how many steps it takes for things to converge on Z? Let's think. In the small case, maybe we can calculate the cycle for each of these. Yeah, okay. So how many times it takes for these to get to Z once? Because I believe that's cyclic. Okay, and if we know, for instance, that this one takes 10 and this one takes 20, then we know that it'll take 20 steps. So we get the, what do you call it, minimum factor between them? My maximum factor, let's think. Yeah, the max, the lowest number that all of them divide evenly into. So 20 divides into 20, and 10 divides into 20. So I think that's how we can do this. The lowest number that all of these divide evenly into. But there might be another concern. What if it's not cyclical? This only works if we know that it's every 10 steps, you know, we'll have what we need. But it's possible that it's not every 10 steps. It could be, what if it's 10 and then 3 and then 6 and then 10, right? So maybe it's not cyclical. So perhaps we could have an array of how many steps it takes to get to Z. Well, I guess we could just examine. We can see how many steps it takes in practice for each of the A ones to get to Z. So let's take this away for now. Let's get back to the original. Oh, actually, this could be useful. I'll comment it out, but well, I think we might be able to still use it. Okay, so what I actually want to do now is for each of these, see how long it takes to get to Z. But there might be multiple ways of doing that, which is the concerning part. So, yeah, right. Well, I guess I'll just try it out for a random amount of steps and then see how long that takes. Because in this one, the actual input, you'll notice it's not that big. So I believe that because there's only like 6 of them, we can calculate the number for each of these and then just like do some algebra, which is going to be a disaster because I don't know my stuff. Right. So now we can steal the old logic back. What? Oh, that was dumb. Right. So maybe you can look at. Oh, this is still running. Yeah, so it's not even done after like 5 minutes. So, okay, maybe. Ooh. Maybe you can look at how long an individual case takes. Okay, so if what I was thinking is correct, we find the. Oh, that sounds like it's way too big. Let's look at the smaller example. Well, wait, no, not that one. This one. All right. So, what is the least? Okay. Least greatest. Wait, what is this called again? Least greatest factor. Greatest common factor. Is that what it is? Is that what I'm thinking of? I think it is. Or least common multiple. Yeah, that's what I want. Okay, so let's. Yeah, okay, so you can use this to find it. Okay. I mean, yeah, that could be right. So take the least common multiple of all of the numbers put together. I think that's a way of doing this. How do you do it for multiple? I think you can just chain them together, probably. Or maybe order them by. No, right. So I think it's a least common multiple problem. Well, let's do this another way. Oh, you know what? Let's just do this twice. That's what I'll do. And if all of these numbers are like double the previous one, I think that means that they're perfectly cyclic. That's not perfectly cyclic, okay. Yeah, you can see that. See, these line up on the second one. I'm surprised you can't actually just keep doing the steps here. Like, the least common multiple. Well, how do I know it's the least common? Because if these aren't aligned, that's a bit of a problem, I think. Well, let's see if. Ooh, that took a while. Is there a common pattern here? Well, even if we did least common multiple, do we know that would be wrong? Let's look at the gap between these numbers. This is fairly really obvious, by the way, but I don't know. 21,000, 635. That looks like a different number. Okay, 21,096 versus. Oh wait, that is the same. So maybe starting from the first number, the gap is cyclic? Well, let's check that out for these. 39,262 minus 23,147. 15,115. 55, 37. 16,015. Sorry, I have bad memory. 16,000. Yeah, that's the same. Okay, let's check the last one, or the third one here. 16,408. 16. Okay, I'm assuming that means that the gap between each of these is cyclical, so it's always the same. So in that case, we take the starting ones, and instead of actually doing all this work, let's just repeatedly add on the gap here. So, what if we just had like a vector of like column? I'll reorganize this later, but I mean, what we really have is that we have a gap, right? So, what's the implication here that I'm trying to get at? So we have like a first step here, and then we have like a second step to the z is what I should say. These should be called like first z, second z, right? So we have a second z. I'm dumb. Hey, hold on, let's redo that. Okay. Print line is ambiguous. What? What are you talking? Is that a real error? Oh, it's not. Okay. Where was I? Yeah. So let's get the second z out here. Therefore, the gap is going to be second z minus first z, which is, of course, what I'm going to rename this to. Local steps isn't even like a real name. And with that gap, we get our gaps and we push that in. Interesting, right? So now that I have the gaps for each current, I just need to know their starting position, which is going to be the first z. So I think what I have is something like this, where if they're not all equal to like the first thing we got, then maybe, oh my god, then I think it's true to say that they're not all equal, right? So perhaps while all equal, and where all equal is this calculation, we're gonna go to each, no. And we'll, increase it by the gap of each thing until they're all equal, right? And once they're all equal, I think we know that they're all going to be the same. Therefore, we could just print out how many steps that took. Not like 1,000, please. I don't know. It's not really sold on that, but let's just see. Okay, wait, 2 is not correct. So it's supposed to be, oh wait, well, it should be 6 for this example. Holding my breath on this. We got an infinite loop. Okay, nope. That's not right. See what we're getting as the actual numbers here. Oh, it's not even. Wait, what? Wait, what's looping for every then? Let's see. Is it this? Interesting. I don't call this looping forever for other examples. No, that's okay. Well, let me just see if we're still getting like same results. Yeah. So why is it looping forever? Let's think. No, right. Ooh. Oh, that overflowed. Right. Which I don't think is correct. I don't think that these numbers are so big they should be overflowing. But we can always just make sure. Okay. Yep, okay, so they never converge. I feel like theoretically this is actually making sense to me. So why would they not converge? So they start here, and then they keep getting added the gap too, right? And we had that before. Although, I don't know about the exact gap. Let's take a look at that. Right, so 21,000 to that. To that. Hey. Yeah, that looks like the gap to me. Oh, yep, that looks right. That looks right. Is the gap not a way to do this? Well, I did only check 2 steps. Maybe it's possible that not all of them have the same gap between them. $18,459. 18,459. No, they have the same. The gap between these is always the same. Oops. Right. And well, let's see what we're getting for numbers then. I actually thought this could have worked. It's possible that some of my conditions are not correct, but right. So this is implying that they just never converge, which is obviously not true. Oh, wait a second. You know what? It's not that they all have to be equal. They can be equal across different points in time, right? So as soon as we have the same number, the first instance, okay, I understand now. I believe we have to look at if I'm gonna do it my current way, I constantly have to look if one number has appeared in all of these. Because that would mean that they all appear at the same step. So it's not that I have to do it like that. It's what I really need is this is kind of weird, but yeah, I need a vector of numbers seen, okay? And what happens is that seen will start with seen will constantly have the oh, whoops. Okay. Alright. So scene will constantly have the number we have inserted into it. And if the same number that we are looking at appears in all of them, then we have 1. So what needs to happen now is that it's really any of the seen numbers, if they appear in any of the seen numbers. Well, it's actually not. Wait, let's think about this. Okay, so it's the latest numbers we have. If, for example, if this was like that, we just need to check if a current number appears in all of the sets. I don't think that will take so long because there's only 6 possible elements to check for. So, okay, instead of being fancy, let's just do this normally. Wait, I'm like losing track of what's what. Okay, so that's a vector. If any of starting is seen in all of these. No, it's any of these seen in all of C. Okay, I see now. That's a little annoying. That's what I'm saying. Is that all of the sets have to contain the number we're looking at. Although, we need to find out which one it is, so, you know, I'll just do it normally. Oh, yeah, why not? Let's see. Ah. This is getting pretty complicated, so let's just at least... Okay, we have 3 steps here. One puts everything inside of our scene set, the other modifies the starting set, and now we run through a new starting set to see if everything we're looking for is there. If it is, then we stop. Oh, right. Little convoluted, but oh, okay, wait, that's not even a normal error. Okay. What was that? I got an indexing out of error, really? Where is this coming from? Oh, okay. So, something here is a little bit fishy. Yeah, I'll do this first. Okay. Yeah, alright, so that's the same. Oh, wait, scene is too small to begin with. Okay. So, yeah, it was a problem with me not initializing things, of course. Alright. Can I do the size? I think that's how this works. That should say how big that should begin as. So initialization problem. Very boring. Alright, this also just never converges. Sick. Okay. Not sure how to feel about that. Well, I feel like that's like not true though. Like eventually you would think, like you would get something. That would match. I feel like that's true. So we don't need that anymore. Right, like, in fact, I could just verify, you know what, I could do this by, maybe not by hand, but just look for it, right, and it appears, okay, so that one only appears once. One of these appears twice, though, right? We have, yeah, like, that appears. Okay, that only appears twice. Like, what exactly am I missing here? I'm looking for the common step that appears all the time. Actually, wait, on the second hand, I just realized. Maybe this actually isn't a good algorithm. Because if the starting is different and the gap is always the same, well, the gap isn't the same, that's the problem, but yeah, so eventually, like this one is always going to be bigger than all of them, I think, or which is, yeah, the gap is 21,000. So as soon as the gap gets really high, you're just waiting for the other ones to eventually latch on to a number that matches. The part that concerns me is that we are not getting any of these numbers to show up anywhere else. I would expect that some of these would, okay, no, some of these would eventually be hit by other numbers, but they're not. Maybe if I go down really far? No. I don't know, I'm gonna let this run just for a while, just to see if... Ooh, yeah, no, okay. Let's make sure that we're doing a suit insertion correctly and all. I believe we are. Yeah. And it just never happens, okay. Like we're at this giant number, so let's do like a small number. This one never appears anywhere else. Never appears anywhere else. And what about this one? No. So these numbers are too unique. Okay, honestly, I'm not sure I can do this one then. Let's look at the stats. Ugh. Actually, wait. Oh, wait, that wasn't bad. But now, yeah, it's not very good. Okay. Because you're only... Well, wait, what am I doing? I should have tested this on the small case to begin with. Right, and this one never finishes, and let's look at why. Okay, wait, that's not very helpful. Wait, that should actually finish, so something is going on here. Am I not adding in the number we need? Let's see. Okay, first of all, we're at 2 with a gap of 0. Let's maybe swap the ordering on this. Let's do this all at the beginning. Whoa, okay, yeah, right. So there's something wrong with my order here. 2 should be inside the set. And then, whoa, okay. Yeah, that really makes no sense now. Okay, the set is 2. And n is 2. So what is going on here? Why is that not being true? Oh, please tell me it wasn't a local declaration issue. I think I might have been redeclaring a local variable. Well, no. Okay, this still doesn't work. Hey, that's fine. Well, I still want to look at the sets we're getting just to make sure, yeah, we have all of our numbers. Wait, what? That isn't... I don't think that's actually correct. Let's... Oh, well, yeah, let's do it like that. Yeah, okay, that is correct, I believe. Yeah, because those line up. Okay. So, yeah, I think this is what I'm trying to do, and I honestly don't know why it doesn't work. Am I missing a really obvious, like, least common denominator? Or least common multiple? Is the number way bigger than I think it should be? Possibly. But I feel like the answer can't be, like 40 trillion, right? Like, that seems like it'd be too big. Let's comment this out for now. So I'm going to give this just a few seconds, and maybe you can see how high the number creeps up to. Because it's really not that many. It's not using a lot of memory either. These are just numbers, so that's to be expected. Maybe I'll let it run until it overflows. Not sure I'll know when that happens, though. It's going at a pretty steady pace. In the meantime, let's make sure I'm using the right logic still. I feel pretty confident about this, so I'm not sure what I missed. I'm gonna be honest. Still going. It stopped using it. Okay, let's see. Oh, great! I didn't print anything, so that gave me nothing. Okay. Well, not that I think I'll really get anything out of this, but we'll do it anyway. Oh, right. We should test the small case. Oh. It doesn't even complete for the small case. Huh. That's very interesting. Okay, well, the output being empty is kind of stupid. Not really sure what's going on there, but strip that out for a sec. What is going on? And it's stuck in an infinite loop, okay. Now I'm even more confused. So perhaps it's an implementation problem. It's possible that my solution still makes sense. So where is it getting trapped in an infinite loop? Here? Why is it printing nothing? Whoa. It's getting stuck here. Let's make sure it's that. Yeah, there's nothing else that could break this, so okay. It's definitely this. What? Oh, maybe it's once we get to here. Well, that shouldn't ever happen, so. Or maybe something gets to Z once, and that's the only time that happens. No, wait, I thought I figured out the problem was not doing this simultaneously, but I think we simulate this simultaneously by resetting our input here, so it can't be that. So one of these gets stuck on X, I think. Is that the... But that's not happening on my big test case, so that's not really... It's not really the problem I'm looking for. We'll cheese this for now. I think it's the second step where things go wrong. Yep. So, but that doesn't fix anything. That doesn't really tell me why I'm not getting the correct answer. Oh my god, what? That wasn't it? Okay. Yeah. Hey, that's not a gap of 1, that's a gap of 0. What? Or a gap of 2. That's what I should meant. Left, right. So the first one has a gap of 2. The second one is this one. 1. Okay, so left, right. Hey, it gets stuck. Oh, never mind. Left, right. Yeah, so that's a gap of 3. So both of these are 1 under the correct gap. Huh. Why is that the case? Oh, what if I just like add 1, you know? No, that doesn't fix it. Hey, 6 appears in both of those. That should stop this whole thing. So why does it keep going? Okay, so this the implementation problem, right? Oh. Oh, everything about this. I understand now. I knew it. Shouldn't have done things like this. Because now oh, okay, so it was a Boolean, I think it was a Boolean flag problem, essentially. So I think we can even get rid of this. Get rid of what is going on here. You know what, I'll do 2 inserts just for fun, you know, it doesn't matter, right? Get rid of that. Get rid of this. Okay, so there was a Boolean flag problem. That would make it so even if we did find a matching number, the whole thing would never stop. But I mean, there could be other problems. So let's it still doesn't finish. So okay, even that was not the issue. Okay, it's good I found that though. The gap isn't 2. What the? Also, why are these completely different numbers than we were getting before? I was getting gigantic numbers. I don't think the gap should be 2 on that. Oh, oops. Wait, I still have this. Duh, even this doesn't work. Okay. That's demoralizing. My last ditch effort is I'm just gonna like add a 1 and see perhaps for some reason my gap is 1 smaller than it should be. No, yeah, that wasn't it. Kind of running out of ideas here, so. Maybe I misunderstood something. Why don't we get stuck on Z? Let's see. So left, right, left, right. Oh, huh. Interesting. Wait. So those shouldn't actually be getting stuck. Where was I? Yeah, okay, so never mind. There is an implementation problem. So that one's getting stuck. It never gets to the second Z. And as for Y, I'm not 100% sure yet. I guess we could just look at what copy we're on. I think I had this solved a while ago, honestly. This is all just implementation problems. Yeah, I get stuck in X, which is not right. Left should go to right, which is 11Z. Oh, what the f... Is there one extra? What was that doing there? Okay, well now it thinks the answer is 3. That's also wrong. It also thinks the gap is 1. That's also way wrong. Okay. Okay, so there was a... Okay, so it wasn't... Of all things to be wrong, I did not expect it to be that. So that was completely wrong. Are we even getting the same answer for this now? I think we got nothing. Yeah, no. Oh wait, no, now that would result in the gap of, yeah, 0 for everything. Okay. But what is the problem that's happening here? So that means we did another step at least. Okay, so this also should be really at the beginning. I don't think that changes anything about how this is done, so that just makes it a little more safe. So we should be getting 2. Still getting 3. I don't even know why. What the the gap is 1. Like, that's not even... That's not even... Why would that even be 3? Okay. Oh, okay. So the first time around we have nothing, which to me does not make a lot of sense. Alright, that results in like double duplicating some inserts, but it also doesn't matter, so just has to be correct and it's still wrong. What the and that's also wrong. Like, it's not 11b, it's left and then right, so it should be 11z. So what's going on here? I knew it. Did that just bite me? I didn't do what I said I should do, which is have a generator for... I said the whole time, not the whole time, at the beginning I said something about having a generator to pick the correct input I. And I think that just bit me, like really bad. Well, okay, wait. Not what I expected, okay. Back called on an empty stream. So, where was I? I think that just bit me. Oh, what is that? That's not even... Right. Oh, that was from the poker one. Right. No, it's still wrong. Oh my goodness. Right. Well, let's at least see what we're getting. Okay, well that's useless. Yeah, those gaps look pretty similar to what we had before, so I don't know, I might just give up soon. I think I had this correct too. I mean, I feel like this makes sense. Like I'm using gap between these to find out when they will converge. Like that makes sense, right? We basically, it's like we have a bunch of velocities and starting positions, and I'm just finding out, you know, the classic problem, when two cars will meet, right? Given how fast they're traveling. And it's just like there's 6 cars, right? We have 6 cars at 6 different locations with 6 different speeds. When do they meet, right? I feel like this is really obvious. Like, I'm just simulating it instead of just doing some math on it. But even if I'm simulating it, I feel like I should still get the correct answer. So I'm not sure why I don't. Okay. Oh, yeah. Yeah, I mean... Oh, wait, why does that go on for so long? It should stop right there. Oh, it's because of... Oh, it's probably because, yeah, we keep going. Yeah, okay. Well, that doesn't matter anyway. Okay. Yeah, well... See, they start at different places, they have different speeds, and they catch up at different spots. So I don't know why that's so like unsustainable for the actual example we have. Maybe they catch up at like 5 trillion, so I should have just done the math on that. Yeah, that was probably it. Well, it's not really just the LCM is the problem. It's the LCM of like a starting position. Hey, wait, those gaps don't look... I'm actually suspicious about those gaps. So they're the same? Wait. Because previously we were finding that the gaps were very much not the same. So. Oh wait, that is a really big number, huh? Okay, so. Yeah, you know what? I was just simulating the whole thing. That was kind of pointless. I should not have done that. So, okay. I had the answer the whole time. Just like I should have just done that. There were other errors involved, so it wasn't just that. But like, yeah, I don't even know what to say. This is just depressing. So I don't even need the gap. I just need starting. Don't even need that. So, it's gonna be the least common multiple of each of these. Do they not have a... Okay, good. I don't know if that actually works. Probably not. Yeah, that's the answer. Oh, that's so painful. So much pain. Like, I had the whole thing, and I did all this useless work, and I debugged it, and I found all this and that, and from like 5 minutes in, I was on the correct answer. I've had this page open the whole time. Didn't have to do anything. I don't even know why I was worried I would have to like think about GCD. Of course they would have that. It'd be barbaric not to. So I don't even know why I did. I guess I wasn't thinking, but yeah. So I even thought of that correctly. I did all of this. That is just so sad. Like I knew the whole time I knew it. I probably could have done this in like 15 minutes, not an hour and 20. Okay. Yeah, no, definitely not first on that one. Okay. Well, at least we figured it out. And you know what? I'm happy about the final, well, the solution we have converged on. So that is good. Till next time.